Hi, I'm David Morgan and welcome to 100 Days of Code. You might be wondering, just where do you go to start this course? Well, we're going to the amazing Replit. From the homepage replit.com, you can click this button down here to start the course, or you can go to join.replit.com/python. Wherever you go, you'll end up at this page. We're going to click to sign in to start the course. You'll be prompted to create your own Replit account. You can sign in with Google, GitHub or Facebook, or create your own. I'm going to create my own. Once you've signed in, you'll go straight to the course page. There's a number of ways to get started. You can literally just click start day one, or you can go down and see the 100 days journey to get a preview of what's to come and see who else is coding on those particular days. To get started, click on day one and the REPL will load. Now you'll probably notice that we've done a lot of the work for you within the REPL. Your tutorial pane is on the left so you can read through all the text. The video pane is on the right and you can move that around, close it, open it, pause it, do what you want with it. You're going to type your code into this main window and click run to run it. When you're done, click mark lesson as complete to move to the next stage. However you found us, we really hope you have a fantastic time learning to code with Replit's 100 Days of Code. Welcome to Replit's 100 Days of Code. I'm David Morgan and I'm going to be taking you through 100 days of code, 10 minutes at a time, to teach you everything you could possibly want to know to start your Python adventure. So let's get started. In the next 10 minutes you'll be learning all about print statements and how to get your computer to output messages to the screen. This is by far the most important lesson you'll ever learn in programming because it's the first thing you need to be able to do. So let's get started. Our first job, of course, is to start by clicking the Create button. This is the creation modal. You don't need to worry about it apart from the fact that we're going to pick Python for our 100 days adventure. And you may need to give your file a name, although I quite like the automatically generated ones. Once you've done that, all you need to do is click Create REPL. Now boom, straight away we're into our development environment. This is the Replit workspace, and there are some key features that we need to look at. First, we've got our files pane. This is where all your files are going to go. This is your main coding window. This is where you're going to do most of your typing, and it's where your code's going to go. Over here, we have the console. The console is the output from the program. So anything we tell our program to show to our users will appear here. Now this bad boy is the run button. It is the thing that makes your code run. So we'll click that when we want to turn the code into a working program. Let's stop faffing about and let's get coding. In the grand tradition of all courses like this, we're going to start with saying hello to our world. What we need to do is type in print brackets. Within those brackets, in speech marks, I'm going to type in hello Replit. And let's click that run button and see what happens. Immediately, we've got something working. This is amazing. So what's all this then? Well, we've learned our first statement, the print statement. And the way this works is that print will take whatever is within its brackets and place it on the console. You might be wondering why the thing in brackets has quotes around it. Well, it has quotes because quotes are our way of telling the computer that we've got a bunch of text that you need to print out. And in our case, a bunch of text would be called a string. So it's a very, very simple setup. Print, brackets, quotes, and whatever you want to print go inside those quotes. As an aside, you can use double quotes or single quotes. In my examples, I'll be using double quotes just for clarity at this early stage. What happens if we need more text? Well, all we need to do is put more of these commands in. And if we click run, we'll see that repeat after itself. Please note that every time we put a print statement in, the output goes on a different line. This is a really great way of spreading all that stuff out in your console and having some control about the way it looks. You can even add emoji by either copying and pasting it or bringing it from your system's emoji picker, and that will pop out on the screen as well. One little cheat that might be useful for you is if you want to write a load of text, press enter a few times and separate all that out. You won't be able to do it with just one set of quotes, but there's a magic set of quotes that lets you do that. When we print, if we add 3 sets of quotes to start, you'll notice the computer has automatically put in another 3 sets of quotes at the end for me. Well, anything I write between those two sets of 3 quotes will be printed exactly. And when I run this, you'll see that the 3 quotes form of printing just copies the text exactly as it appears and puts it on the screen. Now this is really, really handy if you're putting longer bits of text or paragraphs, or you really want to spend your time writing out something that looks exactly the way you want it to pop out the other side. Now, common problems, because code isn't always ease and magic. Sometimes things just go wrong. When it goes wrong though, Replit does try to help you. In this example here, you'll see that we've got a red underline in the code. If you hover over that, Replit tries to give you a suggestion for what that could be. And it says undefined name print. If we to run the code, we'll see a similar error message going on here. A name error, print is not defined. Now you might be thinking, why? You've already told us that print is a thing. This is the very thing we are learning about. What's wrong with you? Well, yes, but not print with a capital P. And that's the issue in this case. We have to be very careful with the way we capitalize things when we are coding, because it is that pedantic. Well, what else could go wrong? You'll see once again Replit is highlighting the error for us, and it says invalid syntax. Let's run it. Why don't you take a pause and have a think about what's wrong in this code? Oh no, it's trying to help us here. It says missing parenthesis in the call to print. And it's even given us an example of how the code should look. And yes, you're right, we are missing our brackets. It's a really common thing again to forget to put brackets in, and it's an easy fix if you do. What about this? You're at your lowest ebb and you've demanded that the computer just works. Please, just work. Well again, Replit's trying to provide us with some suggestions, in this case, invalid syntax. Let's run it and see what it's actually saying. The same error, invalid syntax, but can you spot what's wrong? Have a look. Yes, we haven't put our text in quotes. Without quotes, we are basically telling the computer to print something that doesn't exist. We need the quotes around the text to tell the computer that it is text that we want it to print. Click run, and it actually works. There's some of the top errors you might see or you might encounter in your first day of code. Now, if you want a bit more of a challenge, why not try this? I've created some code that doesn't work. Can you fix it for me? Give it a go. Here is your challenge for day 1. We really want you to get into the spirit of 100 days of code. So we're going to ask you to write a statement of intent to really prove to the world that you want to do this. We're going to ask you to output your first name and today's date on the console. Then you're going to add this piece of text to your output, and ideally only using one print statement for the entire chunk. On the next line, we want you to write I am feeling to tell us how you're feeling about it, but instead of putting your feelings into words, let's put your feelings into emoji. We're going to add one more line to your output. You're going to do this, and after the @ symbol, you're going to put in your Replit username, which is on the screen in blue up here already. Next, run your code. Screenshot it, share it on social media with the hashtag Replit 100 Days of Python, and share your first code output with the world. You might also want to take this opportunity to publish to our community. Click the publish button and follow the workflow to get your code being seen by thousands of other people. Well, great, you've done it. Congratulations, and well done on day 1 of 100 days of code. We'll see you tomorrow, where we advance past just printing something on the screen and look to take something from our users as well. Day 2 of 100 days of code, and big whoop, you can put something on the screen. But let's see if we can take something from our users instead. Now this is the input command. It's very, very similar to print, but what it does do is it shows the text on the screen, but won't do anything else until our user has typed something in and pressed enter. So it looks very much like the input command. Let's test it out. Now you'll see the program's run, but it's waiting for me to type something in. So I'm going to go over into my console, put my name in. Well, It took it, and the program finished because we've seen our replit icon, but it's not quite doing anything exciting with it. Let's change that. One of the issues we've got is that we've taken something from the user, but we haven't put it anywhere. We've essentially gone, what's your name? And immediately forgot it, like all those people we've met at parties. Let's change that. And to change that, we need to discuss the concept of a variable. Now, a variable is a named piece of computer memory, and you can think about it like a box. Now, our variable we can give a name to, and with our variable having a name, we have a place to put something. When my user types in their information, then we can place it in that box so that it's stored within there. If I ever want to access that information, then I just need to tell the computer that I want what's in the box, please, and ta-da! It appears. One thing worth remembering is that variable names can't have spaces in there, so you'll need a strategy for variable names that are descriptive. Most people either use underscores to represent spaces, or they use camel case, where the first letter of each word is capitalized to show where they start and stop. So a variable needs to be created, and then we need to use a single equal sign to assign that variable. In our case, we're assigning them to the input, basically whatever the user types. Let's see how this works. So it's asking me for my name. That gets stored in the variable my name. It's now asking me for my age. That's now stored in the variable my age. Finally, do I like replit? Of course. And that gets stored in the variable replit. Now, the only thing is I haven't done anything with that. I've stored it in the box and filed the box away, never to be seen again. So how can I do something with the contents of those variables? Well, it comes down to our print statement again, because we know that print will show on screen whatever is in the brackets. So far, we've put quotes in and just written text. If instead we give the name of the variable and note no quotes here, because variable names don't need them, then what it's going to do, it's going to look inside that variable and print out the contents onto the screen. This means that extending our code now to print this contents out means I can give it my name, my age, and whether I like replit or not, and it can print that out for me in a sentence. Now hey, don't worry that it looks a little funky at the moment. We're printing it a line at a time. We'll deal with making it look a bit prettier tomorrow. So what can go wrong with this one? Well, our first problem, as you can see again with the red underline, is invalid syntax. If you run it, you'd see this error. And what's the problem? Well, the problem is just that my variable has a space in it, and we know that variables shouldn't have spaces in them. And if you take that away, we end up with a working program. What else can go wrong? Take a look at this. Ugh. Now that is a horrible crash. That's one of those nasty ones that doesn't really make a great deal of sense at first viewing. But you see, it always tries to give us a line number. It always tries to tell us where the problem is. And in this case, it's saying my grandma is not defined. What, is that some sort of diss? Well, it's not, because what it means is that when we went to print it out, it couldn't find that box. It couldn't find a box or a variable with my grandma as the name. And if you look carefully, the reason for that is again, capitalization. We set my grandma up in camel case, and we're actually wanting it in camel case as well. If we change that, it'll print it out nicely. You've got to be careful about how pedantic programming can be about capitalization, and you have to get used to making sure that if you set up a variable and a name in one way, that when you call that variable, when you reuse it, it looks exactly the same. Now we've also got this, which is the worst kind of error. We call this a logic error because nothing breaks, nothing's underlined in red to say that it's not going to work, but there is a fundamental logical problem with this program. Let's try it. What am I having for lunch? Burrito. Well, that's a strange way of saying it. It sounds like you really should just order my lunch as soon as possible. I said I wanted a burrito, not just my lunch. Well, I've made a common mistake here, and that's because I've accidentally put the name of my variable in quotes. Remember, quotes literally print out whatever happens to be in them. In this case, it's the name of the variable, so the name of the variable gets printed. To print the content of the variable, you need to make sure that it has no quotes around it. And when we do it this time, boom, we get the answer we were looking for. For those of you that fancy an extra challenge, I've once again broken a bunch of code. Please fix it for me, please. Okay, here's your challenge for today. We're going to write a program that gets to know your users. You're going to ask them for their name, their favorite food, their favorite music, and where they live, and you're going to store all of that in separate variables that you give names to. You're going to print out a blank line or two. Spoilers, you do that by just doing print and brackets. It'll just print out a line or so. And then at the end, we want a full sentence, like you see on the screen at the moment, that explains all about that user to themselves. Now let's stop by giving them a positive affirmation. Something cool, something exciting to get them engaged. We're going to do something a little bit different this time. Copy the URL at the top of your window and share it on social media with the hashtag #replit100daysofpython and ask your users to try out your program so they can get to know them better. They can immediately click run from that link and try out the code that you've created. It is really, really fun. Let us know what you've built. We'd love to see it. We're doing well. Now tomorrow we're going to look at making these sentences a little bit nicer so everything looks nice and pretty. It's day 3 of 100 Days of Code. You might be looking at the title and going, concatenating? Well, concatenation is just a complicated word that means our ability to glue together bits of text and variables together to make nice full sentences that look good in your output. So you were probably annoyed yesterday that your output looked a bit broken. Everything was going on its own line. Well, let's fix that. Now, in this program, we have printed everything out in a single line, which is quite frankly amazing. And the way we've done that is by placing the different objects we want printed within those brackets on that print statement. Remember, the print statement prints everything out in brackets. But for every different object, we just need to separate it with a comma. And that comma is magic because we can put in as many different objects as we like as long as they are separated by a comma. In this example, I'm going to print out the value of my name, then the sentence is going to be chowing down on, then the value of my lunch, then the text very soon. Let's see that work. Aha! So, a fully comprehensive sentence that is all there in one big block, all achieved by the superpower of commas to join together objects. And of course, you can join together as many objects as you want. But what could go wrong? Well, maybe you've got something like this. Once again, invalid syntax as an error, and when I run it, I get the same thing. Can you spot what's gone wrong there? What are we missing from that bracket? Well, I want to join together 3 different objects, but what's the symbol I need to tell the print statement that they are different objects? It's that magic comma, and we're missing it again. So if I include the comma after the first object and after the second object, that separates them and we should be good to go. Boom, we're sorted. Here's another common error. Now, once again, it's not that sort of error where we get a red underline. So let's see what's going on. Well, it's working. Oh, it's that same error we've seen before, where it's literally printing out the names of the variables instead of the contents. How did we fix that last time? Well, we made sure that variables were not within speech marks. The only thing in speech marks should be strings of text. If you fancy a challenge, once again I've put a bunch of code together to make a custom song generator that I've sort of broke. So if you can fix it for me, I'd be more than happy. Your challenge for today is to come up with the ultimate wacky recipe maker, because We've all been there. When we were kids, we all tried mixing Nutella with mac and cheese and pizza, and let's be honest, it wasn't probably the most successful recipe ever. But let's reinvigorate those days of yore and build a silly recipe generator. I'm going to ask you to ask your users for several variables: a type of food, a type of plant, a method of cooking, a word to describe a burned food, and the name of a household item. And I'd like you to output them all together with these words and phrases in between, so that if we enter a bunch of content, we get a silly recipe like this: the sauté mac and cheese with ruined cactus on a bed of hammers. Now that sounds oddly appealing actually, doesn't it? Maybe you want to remix that and make it your own. Maybe you want to extend it, add more items, maybe add a starter, main and a dessert to the options. Whatever you do, make sure you copy the URL, share it on social media with a hashtag replit 100 days of Python, and make sure that your followers, your friends and random people from across the internet can make their random recipes and share it back with you. Now, day 4 tomorrow, it's our first challenge. We're going to put all these skills together and you're going to make something really cool. It's day 4 of 100 days of code, and your challenge will be a little bit of fun, because we've all seen those companies that charge a fortune to your grandma for a customized storybook where you go and meet Santa. Now, everyone loves getting those, but the people that really love it are the companies that charge a mint to your grandma to sell it to them. You're going to build your own. You're going to build a program that asks for a bunch of key facts about the user and weaves it together in a custom story that will be just about that person. Regardless, you're going to build a custom story for your users. Couple of little hints though: maybe don't ask hundreds of facts up front. Do a few, output a paragraph, and then ask for a few more. That way you can make the story more interesting and more engaging and have the user doing less work to get the results more quickly. Don't forget to publish your rep this time. Click that publish button and follow the steps to get it shared with the community and get some real feedback. Don't forget to include the hashtag replit 100 days of Python if you're posting it on social media. Where I've got a sneaky extra skill for you. Whilst everyone that didn't stick to the end of the video are printing everything out in just plain white text on a black background, we're gonna add color. Yes, we're getting up to the technological level of a computer from 1981. Woohoo! Now it works a bit weirdly because what we're actually doing is we're printing out a command code that tells the computer to change the color of the text that follows to a different color. That means we need to be clever about where we put it, because if we turn on red text, for instance, everything we print from that point forward will be red. So if we only want one word in red, we need to print out the code to turn red on, print out the words, and then print out the code to turn red off. Let's give that a go. In this example, I'm warning my user for being a little bit naughty. And what I've done is turned on a red color, printed out the word warning, and then turned the default color back on. Now all you need to do is make sure you copy that code and change the number from the table for the color you actually want. In this example, I've concatenated it all together just so it's easier to read for me, but you could stick it all in one text box as if it's one complete thing if you wanted. And there you go, you're getting the color you want, which means your story can have a bit more excitement to it now. Maybe you could even have something like this. Whoa! Using my superpower, which is in a different color, we'll now know that in my story, I'm going to be a champion. Why not use color to add extra spice to your authorial masterpiece? You've completed your first project. You should be rightly proud. Next time, we're going to look at an if statement and how to get the program to do something different based on what the user has typed in. Welcome to day 5 of 100 days of code. We are getting there slowly. In the previous videos, you've learned all about variables, inputs, and outputs with print. Now today, we're going to get the computer to do something for us and actually make a decision. We're going to learn about if statements, and this is the foundation to how all modern software is designed. So an if statement is a bit like asking a question to the computer. We're going to say to it, if something is true, then we're going to do one part or one aspect of the code. And this works very, very simply. We're going to start by asking a question and storing it in a variable just as we have done previously. With that out of the way, we can start asking a question. And in this case, I'm going to check to see if the name that the user entered is my name. So this first line is the question. We've got the command word if, and then we've got the condition. Now the condition can be thought of as the actual thing we're asking the computer. And we've got a comparison here. How do we know it's a comparison? Well, it's that magic double equals in the middle. That is the equivalent of asking a question like, are these two things the same? And the computer will look at these two things, in this case the variable my name, and the text David, and if they match up, then it's going to run the line of code or the lines of code directly underneath it. Now you'll notice here that Replit's tried to help me by indenting the line of code that I'm trying to write on. And let's start simple, let's print out something cool. The if statement will do all of the lines of code that are indented at least once that sit immediately underneath it. If we run this program, you'll see exactly what happens. If I run it and I say my name is David, which it is, well, it's going to say welcome to me. If I run it again and pretend my name is Angela, well, it doesn't care about me, so it's ignored that. There is one slight problem with this, and it's that pickiness again that we've seen before. If it asks me what my name is and I'm too lazy to put capitals in, then it doesn't care about me either. So, whilst if statements are great, they work on a very, very exact basis. We are literally talking about matching up even the capitalization. So keep that in mind as you go forward. We can, of course, add more lines of code than that if we'd like. Notice that everything I'm typing is indented after the if statement at least once. That means it's all part of the code that we run. And now if we run the code and I say my name is David, it'll execute both the lines. Now at this point you might be thinking, well, that's great for you, David, but what about everybody else? My name's not David. Most people in the world, believe it or not, are not named David, and that's fair. So an if statement has a matching statement called an else. Now an else doesn't have a condition. It is literally just the word else, but key to making it work is that it must be the first thing, unindented after the if statement, and in line with it. That sounds complicated, but let's see it actually work. I'm going to backspace so that my cursor is in line with that if above it, and it's the first thing that's coming back in after the if statement, and I'm simply going to type else colon. Once again, when I press enter, Replit's going to help me and indent my code a little bit, and here I'm going to write the code that's going to happen if somebody that's not called David turns up. And once again, we could write as many lines of code as we wanted to there, but let's run that and see how that works. So I'll say my name's David, and I get the same response as before. Notice I didn't get that line, who on earth are you? Because if and else are selective. If the condition is matched, then it will do the first part of the code, and it will ignore the second part. Let's try something else. Now it's just saying the second part because the condition didn't match, so the computer immediately jumped to the else and ran that code. And once again, you can have multiple lines of code here if you'd like. Your job now, go and implement something broadly similar. See if you can get it to pick up your name and give you a nice welcome message, whilst being a bit mean and grumpy to anybody else that tries to use your computer. Take 5 minutes and build something cool. Pause me. Click pause. You're back now. You're back. Cool. Well, let's have a look what could go wrong, because there's a bunch of stuff that can go wrong. So here's a very simple program that's going to ask if you're a cat or a dog person and give you an appropriate response based on what you've picked. But there's a problem with it. Let's run it and see if we can work out what that error is. Oh, it's our old friend invalid syntax. So that usually means we've typed something wrong. But what did we type wrong this time? Have a look and see if you can spot the obvious mistake. Did you notice that we only used one equals in the if? There is a big difference between a single equals and a double equals in programming. A single equals changes something, so it changes one thing to another, and a double equals is just a very simple question. Are these two things the same? We need to make sure that we remember that in an if statements condition, we use the double equals. By changing that, the program should work, and shocking no one, I'm a cats person. Ta-da. Another problem you might encounter is on the screen at the moment. Let's run it and see if we can track down that issue. It's our invalid syntax problem again, but can you see exactly where the code is pointing to? Our error message is telling us there's an error just after the word cats. So what are we missing? Did you spot it? We're missing the colon. It's one of the most common mistakes I see in students. Missing that colon means you've not said to the computer, well, this is true, then do this. The colon is the then do this part. Without that, you're just saying, if this happens, cool. And of course, the computer, when trying to run the code, goes, what do you want me to do? I don't know. So that colon is really, really important in that setup. Our last error. Let's run it and see what's going on. Oh, this is a different error for a change. Indentation error. Well, what does that mean? Have a look. The indentation in Python is part of the syntax. It is how we explain what we want to happen. After an if statement or an else, as soon as we see a colon, the next line should be indented further than one before it. This tells the computer that everything indented is what should happen in that exact condition. In our case, we've forgotten to indent that last line, and therefore things are not going to work. If we fix that by clicking there and pressing the tab key, when we click run, the program runs perfectly. If you're looking for more of a challenge, once again, I've broken some code. Take a look. Okay, challenge time. This one's going to revolve a little bit of thinking from you because you're going to build a which character are you game. Now I'm sure we've all played these ourselves, going through and picking out our characteristics and being told that we happen to be Ron Weasley. Well, you're going to build that exact same thing with a series of if statements that ask a bunch of questions, finishing off with one final if statement with an else that picks a character if you've not said yes to anything previously. You get to pick the fictional universe of your choice, be it a game, a TV show, a book series, or a series of movies, and identify your friends and your family as a character within that work. This should be a bit of fun, especially for you to poke a bit of fun at some of your family. Let's see what you build, and please put that hashtag on there, Replit 100 Days of Python, when you share it in the community or on social media. Encourage people to post and tell you which of those characters you ended up being. Tomorrow, we're going to be looking at an elif, which is an extension to this if and else stuff, and make it so that you can ask follow-up questions, so you can really dig into what that user wants. Welcome to day 6 of the 100 Days of Code. Yesterday, we learned all about if statements and being able to choose which code path we go down based on a question that we ask. Today, we're going to look at the elif statement that allows us to ask more questions and get more options in the same code block. The elif statement is really, really powerful. It allows us to ask a second, third, fourth, or 156th question to the computer based on the same inputs we started with. This means that I can say, if this, or this, or this, or this, and then everyone else. So I can have lots more different specific states. Before we start though, bit of a warning. Elifs have to go in a certain place. You can have as many elifs as you want, but they must go after the if and before the last else. This is because the else means everything else. And so you can't have options before that. Here we've got a reasonably simple login program using the skills we've learned so far. But you know and I know this is not the way the internet works. You don't build a website where only one person can log in and it tells everyone else to get on your bike. This website is fundamentally broken, so let's add some elifs to expand upon it. I'm going to make some room just after the code for my if statement and before my else. I'm going to make sure that I backspace because I need to be in line with my if and my else that it's all connected to. And I'm going to write elif, short for, of course, else if. An elif works just like an if statement in that we do need to ask it a question. So let's see if we can deal with Suzanne. Now it's a very simple program at the moment. It's just saying hello specifically to Suzanne in a different way. But if I run this program, I can tell it that I'm Mark and get a specific message for Mark. I can tell it that I am Suzanne and get a specific message for Suzanne, or I can tell it that I'm Johnny and get the message that everyone else gets. This is a very, very simple way of adding as many of those as you want. If I have more users, well, it's very, very easy. I click after my previous elif, but before my else, make some space by pressing enter, making sure that I backspace so I'm in line with the indentation on the left hand side, and then add my next elif. You can go and add as many of these elifs as you want to any program and have much more flexibility about how it works. Now before we carry on, this isn't much of a login system because there's no password. So let's go and add some password code. Now how do we check that a user's username and password are correct? Well, think about the way I said that. Username and password. When we speak in English, we can join things by adding Boolean expressions like and, or not. In this case, we literally need to go into our if statement and change the condition a little bit. If the username matches with Mark and the password is the same as password because Mark isn't very secure, then we'll log them in. Let's change Suzanne. So if the username is Suzanne and the password is equal to Suzanne's password, which is a little bit more secure than Mark's, then the only way that these if statements work now is if it matches both of them. Let's give that a go. So my username is Mark and my password is password. Well, hey, I've logged into Mark's account. Let's see what happens if I put my username as Mark and my password as Mark. Doesn't want me there. How about if I try Suzanne's? So Suzanne and boom, we get in nice and easily. Common errors. Well, apart from the ones we've seen before, there's only really one common error that people get with elifs, and it's putting it in the wrong order. Take a look at this code on the screen at the moment. It's the same program, but we've broken it by putting something in the wrong place. Let's run it and see if we can track down that problem. Straight away, it's pointed to line 7, our elif, and said that it's invalid syntax. And let's have a look why. What's happening before line 7? That's right, we've put our else in. The way we've structured this program, we've said, if Mark logs in, say hello to Mark. But for everyone else, say go away. Is the equivalent of us going, actually, if it's Suzanne, it's too late. That's not how the program can be structured for it to work. So this entire chunk of code needs to be moved. I'm going to cut it. I'm going to make some room, making sure to backspace so I'm in line with the ifs and the elses that I want to connect it to. And I'm going to paste back in there. That code now should work perfectly. If you're looking for more of a challenge, once again, I've broken some code. Take a look. Okay, challenge time. I'm going to be asking you to go off and create a program that does something very similar to that login system that we were just looking at. It's going to ask for a user's name and their password but it's going to give a specific greeting to each individual user and show them a specific personalized greeting that will give them a very nice start to their day. You must include at least 3 people, as well as an else command that deals with people that shouldn't be logging in. Once that's complete, don't forget to share it with the hashtag #replit100daysofpython, either if you publish it in the community or on social media, and see just how the community reacts to your simple login system. We'll see you back here tomorrow for the end of the first week, where we're going to look at a special idea called nesting, where we can put an if statement within an if statement. See you tomorrow. Day 7 of 100 Days of Code. You've made it to a week. Well done you. We've learned all about inputs, variables, printing to the console, and if statements, elifs and elses. We've got a whole bag of tricks now that allow us to build something really cool and really unique. But there's one more cherry on top. The concept of nesting, where we put an if within an if and ask follow-up questions. This is how we crack it, everyone. This is how we build the ultimate program. So far, we've built programs with if statements, and the code we wanted to run as part of that if goes underneath the colon and is always indented at least one place further than the if statement. We're going to use the magic of indents to put an if within an if and ask a follow-up question to one we've already asked. Okay, so here we have a very simple program which asks our user what their favorite TV program is and gives some opinions. Now let's assume that we want to go a little bit more in depth with some of those questions. Now, I have a very small child who is obsessed with Peppa Pig, so if somebody says to me that Peppa Pig is their favorite TV program, I want to prod and ask a few more questions. So let's follow up with a question. I'm going to make some room inside the if statement itself where the code needs to go. Remember, that needs to be indented underneath that if statement. And I'm going to ask another question and store the result in a variable. With this done, the program is going to ask who the user's favorite character is, only if they've said their favorite TV show is Peppa Pig. I'm going to put another if statement in now to deal with that. When I start typing the code that should run on this if statement, it's indented again. So we actually have 2 indents in front of it. If I'm putting an else that should be linked to this if statement, it does need to be in line with this if statement. So this is where these lines that we've been seeing appearing down the side of the page come in really useful. The lines, the little thin lines after each if statement, shows how far that if statement actually goes. The line that goes straight down from line 2 to line 8 is everything that is involved in that code. Whereas the lines coming from line 5 to 7 show that it only executes line 6 if the question in line 5 is proved to be true. Let's test it out to see how it's actually going to work. So let's start by saying any other TV show. We got to the else criteria. Okay, let's try Paw Patrol. The first elif picked that up then and gave us the second statement. But let's try the one we've been waiting for, Peppa Pig. You'll see that the code execution has gone now into the second if statement. It's asking us for our next data entry point. So let's say the only correct answer, and so that Daddy Pig is our favorite character, and we get the correct part of that if statement accessed. Now, what I'd like you to do is pause me for a second, go and get this code, copy it, test it out, and then extend it so that you change it to TV shows that you like and you ask follow-up questions that are meaningful to you. Change at least one of these questions, expand upon it, and take some time to do that before you get to the challenge. How about your common errors then? Well, if you're remembering your indentation correctly, there's not a lot that can go wrong here that we haven't looked at before. But there is one common problem, and that's when you're getting to an if and an else within an if, this can go wrong. Now we're getting our invalid syntax message, this time on line 9 by the elif. So let's take a look at that, and hopefully you can see that it's not actually that line that's causing the problem. What's happened is that lines 7 and 8, which is just above it, is indented incorrectly. Look at where that else matches up to. That else on line 7 is in line with the if on line 2. That means that's what it's connected to. That's what it is the else for. Not what we were trying, which was the else for lines 5 and 6. So we'll fix that by highlighting both lines and pressing the tab key to indent both those lines at the same time once more. You'll see now the else is indented the same as the if statement on line 5, meaning that it's connected to that. And the program works as we'd expect it to. As you go through nesting, you'll get more and more used to if statements, elifs and elses, and how putting one construct in another can cause confusion. It's also worth at this point noting that you can have an if statement in an if statement in an if statement in an if statement, and so on and so on and so on. You can put as many of these bad boys in each other as you want to get the flow of your program working correctly. Once again, if you fancy an extra challenge, I've provided some broken code that you can try and fix. Okay, your challenge for today. We've all admitted to liking something in public and started questioning us at length to check that we're the real deal. That we're not fake gamer boys or fake anime fans. Well, you're going to create a program that does just that for something that you're interested in. Let's write a program that asks what somebody's interested in and uses nested ifs to ask a bunch of really annoying, awkward follow-up questions. Let's see if we can decisively, once and for all, express if that person is a fake fan of the subject they're interested in. Don't forget to share it in the community on social media and use the hashtag #Replit100daysofPython to advertise your fantastic program. You're a week in now, what you're building is meaningful and exciting. So make sure you share it and get some feedback. That's it for day 7. Tomorrow is the second big project you'll be able to tackle. Come back to build your own custom affirmations or insult generator. It's day 8 and it's an amazing project idea. You're going to use all your time today to build something amazing. So you've got some brilliant skills at the moment. You've got the ability to choose which code to run based on an if statement and a question. You can even nest those so you can have follow-up questions if you'd like. Well, what I'd like you to do with this then is use these superpowers to build either a custom affirmation generator to give yourself a bit of a positive message every single day, or if you're not that way inclined, a custom insult generator that works on your friends in interesting and exciting ways. What I'd like you to do is ask the user for their name and then ask them some follow-up questions. For instance, what's the day of the week? What's their favorite thing to do? And then I'd like you to generate a custom positive message for them to take away for their day. You decide how you want to connect the various variables that you will take with the if statements and the nesting to give the exact perfect positive affirmation to each user. You may also want to use concatenation to include their name or the key facts about them in any message that you bring up later. If you're building an insult generator, please be reasonably kind. We don't want anyone suffering any long-term mental health issues as a result of the names you're going to call them. But once again, you want to take their name, you want to take some information about them and construct something comical to say at them to entertain. The ultimate stretch though is if you can work out how, in your if statements, to not care about the capitalization of the name. That's right, I want you to deal with both the lowercase version of a name and the version of the name that includes a capital letter at the start. There's only one keyword I want to give you, and that's or. If you were to replace the and concept we thought about before with the word or, you could have an if statement that had multiple possible conditions that would set off the code within it. Have a think about that as you explore this task. Here's a really common error that people get when they're trying to join if statements using logical conditions like and or not. In this example, I'm trying to ignore the capitalization of the name to always say hi to Dave, and it looks like it should work, but let's try it out. If I run it and say my name is Dave, well, it works perfectly. But if I run it and say my name is Bob, well, it's still saying hi to Dave. So what's going on here? The problem here is that the way we read the if statement seems okay in our head, but the computer doesn't understand it. And the reason for that is the left hand side is working correctly. It's saying, is the name equals to Dave? That works perfectly. That's a question, a full question. The right hand side though is just saying, or does the word Dave exist? And there's no question there because Dave exists, it's text, we've created it. So that's always going to be true. So no matter what we put into this if statement, if I say my name is Hercules, it is still going to run the code for that if statement. And that's not what we want at all. So how do we fix it? Well, it's really, really simple. We just make sure that every time we have a logical condition, we restate the full question. Variable name, comparison symbol, value. After every logical condition. No matter how many we put, we have to have that set up. So now if we run it, Dave works as expected, lowercase Dave works as expected, and Bob gets told to jog on. Once your generator is complete, publish it to the community or share it with us on social media with the hashtag Replit100 Days of Code, and please make sure to get some feedback from your friends and family. We'll see you tomorrow when we're starting a brand new series of learning the next 4 days, where we're going to start with an idea called casting that allows us to use numbers in interesting ways. It's day 9 and we're going to deal in casting. No, I'm not going to teach you some magic like Harry Potter. We're going to look at how we can use numbers in an effective way. Okay, until now, you probably tried using numbers in some of your questions and some of your answers, and you can't do a lot with them other than just checking that the user's typed in a number in exactly the same way that you've asked. Well, that's a bit of a lie, because if statements don't just support our double equal symbol, they support this entire range of symbols that you can see at the moment. These questions are called inequalities. We've got not equal to, so if both boxes are different, that will trigger the if statement. We've got less than, greater than or equal to, less than or equal to. All the classic inequality questions. But if you try to use any of those inequalities, greater than, less than, the way we're doing it at the moment, it just won't work. And the reason for that is because the way input has been working behind the scenes is that input always assumes that what you type in is text. In other words, gets stored in a variable with quotes around it, assuming it's a string. Now, that's a reasonable assumption on the part of the computer because it's being typed in with a keyboard, and a keyboard, as you imagine, turns out to be mostly letters. But in certain cases, we want the user to type in numbers, and we want the computer to specifically refer to them as numbers. And the way we do this is with a process called casting, where we explicitly tell the computer what you're expecting to be typed is going to be a number. Now, just a little warning, we do get some crashes if the user tries to type anything else. That's perfectly normal at this point, don't worry about it. Okay, we're going to start with this piece of code that I've written very simply to incorporate the different equality symbols in the if statement condition. In other words, I've written a question that says, what score did you get in our game? Any number over 100,000 should make the computer say winner. Anything less than that should cause it to say try again. Why don't you go and try it and see what happens, and then we'll do it together. Okay, so hopefully you saw the same sort of thing happening. Let's say that I got just an amazing score, well over 100,000. Well, it completely crashed the program. It didn't even not work. It completely crashed it. Now let's try and decipher that error message a little bit. It says the greater than symbol is not supported between instances of string and int. Well, what does that mean? Well, have a look at the way that I typed a number in. I put nothing around that number at all. I type that number in absolutely as it comes. That's because to a computer, a number wouldn't have quotes around it. And that's quite interesting because that means when input works and the number goes in, the computer puts quotes around it. And as far as we're concerned, in our variable box, that is the text version of that number. How do we tell the computer, hold on, sunshine, that's a number? Well, it sort of depends on what kind of number it is. There are two types of number that we need to care about, an int and a float. An int is a whole number, in other words, there's no decimal part to it, and a float is a number that we expect to have a decimal. It only matters what you pick here if what you're expecting to be typed in is going to be different. I want a whole number for this score, so I'm going to use int. And what I'm going to do is in front of my input, I'm going to type in int and place the entire input in brackets. Now, of course, the order at which the computer is evaluating this expression is important, and it does the brackets first. So the first thing it's going to do is this. It's going to put your score on the screen and take that value in from the computer. Now, at this point, it still has quotes around it, so it thinks it's text. What the int part does is it says, hold on now, sunshine, this isn't text. This is a whole number. Can you convert it for me? And the computer goes, oh, it is a whole number. Wow, here, have the number back. And essentially just removes those quotes and hands it back to you. Then it stores it in the variable myScore as a number. When we come down to that if question again, it's able to compare two numbers. And if one of them is bigger than the other, it will trigger the if statement. Let's try it. Well over 100,000. And I'm a winner. Let's check it works though. What if I had such a bad run that I got minus 100? It works perfectly. We are now able to take any input and turn it into a whole number with int. What about a decimal then? In this example, I'm doing exactly the same thing. I'm asking my user to type in pi to 3 decimal places to see if they remember what it is. And all I'm doing is casting that input as a float. That means I'm expecting a decimal. And so it won't crash if I put a dot and then the numbers after it. Let's test it out. Boom! Worked perfectly. Let's get it wrong. And the if statement is matching up those decimal numbers with reasonable precision, which is really, really good. Okay, common errors you might get in this. Well, the most obvious one is this. This is the most common error we get. This invalid syntax error is because we haven't actually finished the brackets on line 1. But look where it tells us the error is. It tells us the error is on line 2. And this is a common problem that we get when we're combining lots and lots of brackets together now. Just remember that on each line, where there's an open bracket, there must be an equivalent close bracket somewhere. So in line 1, we have 2 open brackets and only 1 closing bracket, meaning the problem is there. Where the brackets are placed does have meaning, so please don't just throw them in willy-nilly to see what happens. Try and use your logical approach to working out where they should go. Casting is saying, take what the user types in this bracket and turn it into an int or a float, whatever we're looking for. And then we can do mathematical comparisons to it. Why was the error in the wrong place then? Well, as far as the interpreter is concerned, that line hadn't finished. Line 1 extended onto line 2, and then something weird happened in line 2. So clearly the system is trying its best to guess where that error could be. You've got to be mindful of that. Oftentimes the error will be in just the wrong place entirely. Always look at the previous line just in case you've missed out brackets or quotes that could be causing it to think that that line runs on forever. As usual, if you want another extension activity, I've broken some code and placed it in the REPL for this. Go and fix it if you want a further challenge. Your challenge for today. we're going to work with a person's age in years, and we're going to tell them exactly where they sit in terms of the type of generation they are. Personally, I'm a millennial, but we've got this list of generations and the years in which they were born. We would like you to ask a user to type in the year they were born, and from that, identify which generational group they belong in. Please share your project with us in the community with the publish button and on social media, and make sure to hashtag it with Replit 100 days of code so we can all see what cool stuff you've been getting up to. Day 10 tomorrow, we're going to try taking the fact that the computer now knows that we are using numbers and introduce it to a little bit of math. But don't worry about it. We'll get the computer to do the math for us. It's day 10, time to introduce the computer to a little bit of math so that all the complex calculations in the world can be worked out by this super quick brain that can do math faster than we can think. So far, we've introduced the computer to the concept of numbers, and we've got two kinds: floats, which have a decimal, and integers, which are whole numbers. All of the math we'll be looking at today is very straightforward, but can be applied to both sets of numbers. Now, in a computer, we can set a variable to the result of a mathematical function. This is a very simple way of doing math and printing out the answer. The mathematical symbols that we use are the standards of addition and subtraction, as well as multiplication and division, represented by the asterisk and the / symbol, as well as two interesting concepts: modulo or modulus, which is the remainder of a division, the divisor, which is whole number division. All of that stuff is really useful, and it's stuff that we can use over and over again, and we can combine with brackets to do amazing things. In terms of all the math you could encounter, here's a basic rundown of the usual suspects. Adding, just using the plus symbol; subtraction, the minus symbol; multiplication uses an asterisk; division uses the /. To raise something to the power of another number, we're going to use two asterisks. We're going to use two asterisks. Modulo is the percentage symbol, which again gives us the remainder of the division, and divisor gives us whole number division and is accessed through two /. Pause the video, copy that out, mess with the numbers and see what happens. See how they're working things out. If you want a challenge, once again, I've broken some code and put it there for you to please help me fix it. We're going to start by building a very simple program to break the bill up between you and your friends when you've gone out for lunch. Our first job is asking the user what the bill amount was, and we're going to store that as a float in a variable because it probably will have a decimal. Our next job is to ask for how many people there were in the party. I've stored that as an int because the number of people is likely to be a whole number. It's very irregular that 0.3 of a person comes for lunch and the other 0.7 stays at home. Now, to work out what contribution each person would make if they go Dutch and split the bill, we just need to divide the bill by the amount of people. So our answer is going to be equal to the bill divided by the number of people. I'm going to print that out. I've concatenated that answer together with a bit of a sentence to make it make sense when we run it. Let's assume that we had a bit of a party and spent $80 on food between 4 of us. That's some math we can probably do in our heads. Well, we owe $20 a piece. Let's try it with a bit more of a complex sum. Let's say we spent $120.32 and we're splitting it between 7 of us. Well, whoa. Okay, first of all, thank you math, but I don't happen to have 18.85714285714 cents on me today. How do we normally deal with that in real life? Well, we round up. So a sneaky extra skill is the round function. What we can do is we can take our answer and make it equal to the rounded version of the answer. Round has 2 arguments. The first one is what am I rounding? The second one is how many decimal places. And I'm going to pick 2. And this will properly round up, round down. Well, that's a lot nicer and gets the answer a lot quicker. Hold on, David. Were you raised in a barn? We have to tip. Well, in fact, that's what your challenge is going to be. You're going to attempt to build something that calculates a tip based on a series of different percentages. You're going to write a program that asks the user for the total bill. You're also going to ask them for the percentage of the tip you want to get. 5, 10, 15%, it's up to you, let them type it in. You're then going to multiply those two values together to work out what the tip amount would be. You're going to add that value to the original amount, so you've got a total for the bill. You're then going to ask for how many people you want to split the bill between, work out the division, and output the answer on the screen. Don't forget to share your code. We'd love to see what you've done. Remember the hashtag Replit 100 days of code to make sure your code is seen by as many cool people as possible. Come back tomorrow where you're going to calculate how many seconds in a year just by the power of the computer alone. Welcome to day 11, where you're going to calculate how many seconds in a year simply by the power of breaking a program down into its parts and coding it into Python. We could Google this, absolutely true, but we could also try and work it out. Your challenge is to work out how many seconds there are in a year. So to get you thinking along the right lines, it's worth remembering that there are 60 seconds in a minute, 60 minutes in an hour, 24 hours in a day, and a slightly different amount of days depending upon which month, but usually about 31. There are also 12 months in a full year. Using that extrapolation, you can multiply together a bunch of numbers to work out, roughly speaking, how many seconds are in a full year. But it ain't as easy as that, because the year could be a leap year. And if it's a leap year, it's going to have an extra day. So you will need to use an input and an if statement to add that extra day if it is a leap year. The correct answer usually is this to help you out and see if you get into the right place. But you're going to be needing to think about the order of operations, where best to place brackets to get the math to work the way you want it to. And most importantly, I want the computer doing all the hard work for you and you doing the thinking beforehand. When you've got something, share it in our community with the hashtag Replit 100 days of code, publish it to your social media and get some feedback. See if you can find an easier or nicer way to do it with a bit of Googling. Tomorrow, the ultimate project. You're going to debug a huge chunk of my code. Day 12. This is where you really show what you've learned by debugging some code that I've purposefully broke. Now, I'm not doing this to be mean, but you've been coding now for 12 days and you're doing really well. You've done some interesting things. I'm sure at some point you've been stuck with something that in retrospect was really simple. A quote in the wrong place, a bracket in the wrong place, missing out on indenting a line. We've all been there. Part of the fun of programming is finding that problem and squashing those bugs. So that's what you're going to do today. I've given you a few programs, all with a significant problem. Your job is to run that program, try and identify from the error message where the errors are and fix them. And I won't lie to you, some of these programs have multiple errors. See what you can do. Share your solutions by publishing them with the hashtag Replit 100 days of code, and we'll see you in the comments. Tomorrow, our first big project. You're going to be building a system that will calculate a grade for any subject or test ever taken. Welcome to day 13, your first major project. This is going to take some thinking about, but will be brilliant once you've got it working. Your first major project tests a bunch of the key concepts we've learned already. And it's reasonably straightforward in idea. You're going to ask the user to type in the name of a test, how many marks that test was worth, so what they could have got at maximum, and then ask them to type in how many marks they actually got. You're going to work out the percentage they got and round it to 2 decimal places. You're then going to use a series of if statements and elifs to decide what grade they got. The percentage grades are here on the screen at the moment. 90 or above is an A+, 80 or above is going to get you an A, 70 or above will get you a B, and so on, down to that dreaded U ungraded at less than 40%. I know what you're thinking. I could always do with this program. It's really handy. Yes, it is whenever you're doing assessments to work things out really quickly. There are a number of caveats and interesting quirks you'll find as you go through it, but the aim is to report to your user at the end the grade they got and the percentage they got. Extra marks if you've done something interesting with that. Maybe you gave them an emoji for the grade to tell them how pleased you were, or you changed the colour depending upon how good or bad you think that grade could have been. When you're done, share that work with us in the community and on social media using the hashtag #Replit100daysofcode, and we can see exactly how well you've succeeded in the comments. Tomorrow is your first game development. You're going to make a version of rock, paper, scissors that you can play with a friend. The first two-player game in your portfolio. It's time for you to build two-player rock, paper, scissors. Now, we've all played the childhood game of rock, paper, scissors, and probably all tried to cheat with Lizard Spock or Dynamite or other things later on. We're going to make sure we only deal in rock, paper, scissors for this particular game. Now, you are going to start off with a spectacular line of code that I've snuck in for you. So please make sure you start with a line of code that's here on the screen for you. This will make sure that whenever you use input, each player won't be able to see what the other one typed in. It will hide what they're typing in from the screen, which means the game is a bit more fun than just seeing the words rock and then you guessing paper. So this will help you out. The brief is simple. You have two players, player 1 and player 2. You're going to ask player 1 for their move. You're going to ask player 2 for their move. And then you're going to use a series of if statements and probably nesting to decide who's won, who's drawn, and what the result is. Extra props if you use emoji to illustrate the moves, if you give some sort of amazing commentary to what's happening in this epic battle of the ages between two players in rock, paper, scissors. And my ultimate hint to you for this project is make it nice and simple on yourself. Don't expect the user to type in rock, paper, scissors. Explicitly ask them to type in R for rock, P for paper, and S for scissors. And don't worry about it if they type it in wrong. We'd love to play your two-player game. If you want to share it with us in the community by clicking on the publish button and following the workflow there, or sharing it on the social media of your choice. Use the hashtag Replit100daysofcode to get involved in that conversation. Day 15 tomorrow, we're going to deal with loops. Yeah. See what I did? Loops.